Good morning. Welcome to TMMS Productions. This is yet another video of the series in which we will be solving problems based on geometric progression. Let us start with question 1. Find the sum of first 10 terms of the GP 1, 5, 25, ... Now here we have been given that it's a GP. The first term will be A1, so we will write A equal to A1, which is equal to 1. And 5 becomes A2, 25 becomes A3. But because it's a GP, we must find out what is A and what is R as well. What is R? R is the common ratio. How do we get common ratio? It will be A2 upon A1. So it becomes 5 upon 1, which is equal to 5. Now, we need the sum of the first 10 terms. So we know that n is equal to 10. Also, we have the formula for the sum of n terms, which will be a into r to the power n minus 1 upon r minus 1 if our r is greater than 1. And we also have the sum of n terms, which will be a into bracket 1 minus r to the power n upon 1 minus r, and this will be if r is less than 1. Now in our question, r is 5. So we will say therefore r is greater than 1. And so we will use the formula Sn equal to this one. So let us write it. A into r to the power n minus 1 upon r minus 1. And we also write because r is greater than 1. Now let us substitute the values. A is 1. R is 5. So 5 to the power, it will be 10. N is 10 minus 1. And here denominator r minus 1 becomes 5 minus 1. Now in the numerator it becomes 5 to the power 10 minus 1 upon 4. Now our problem is how to get 5 to the power 10. Now it's going to be a huge number, but let us see what we can do. Now we know that 5 to the power 10 becomes 5 square to the power 5. 2 into 5 will be 10, which means it is the same as 25 to the power 5. Alright, now let us see how we can proceed for solving this. 25 into 25, we will multiply how many times? We will multiply it 5 times. Now do we know this is 625, this also 625? And so we will have 625 multiplied by 625 multiplied by 5. Now I'm going to ask you to look at my quick calculations video in which we have the technique for the number ending in 25, how to make the square of it as well. So we will have 625 square multiplied by 5. So we divide the 625 into 6 and 25. Now number ending in 25, the square number ends in 625. And the part over here, this side, it will be 6 multiplied by 65. And so that gives us 6 5s 30, carry 3, 6 6 36, 39, 390, 625. So this is our square of 625, and now we multiply it by 5. When we have to multiply by 5, again remember 5 is 10 upon 2. So I'm going to put 1 0 and I'm going to make half of this. So half of this is going to be equal to 2 1s, 2 9s 18, 2 5s 10, 2 3s 6, 2 1s 2, 2 is 4, 1 remain, and this 0 gives you this. So we have 5 to the power 10. It's a huge number. 1, 9, 5, 3, 1, 2, 5, minus 1 upon 4. And that gives us in the numerator 1, 9, 5, 3, 1, 2, 4 upon 4. Now 4 will divide this number. So it will be 4 4s 16, 4 8s 32, again 4 8s 32, then we have 4 2s 8, then we have 4 8s 32 and 4 1s 4. So you see we have a big huge number, but we have our answer. Let us come to question 2. How many terms of GP root 3 plus 1 upon root 3 plus 1 upon 3 root 3 plus dot 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 must be added to obtain a sum of 364 root 3 upon 243. Now here this GP can be represented with a plus or minus sign. It simply means that our first term is root 3, second term is plus 1 upon root 3. If it were minus here, then we would have said that the second term is minus 1 upon root 3. That's the only difference. So this is another way of representing a GP. Now we have a sum given to us. And we have to find how many terms, which means you have to find n. So as usual, we have to proceed finding a, that is the first term, and the common ratio, which is r. So we will say a is equal to a1, which is root 3. This was simple enough. And then our r, which is the common ratio, will be a2 upon a1, which means 1 upon root 3 upon root 3. That gives us 1 upon root 3 divided by this means 1 upon root 3. You multiply by 1 upon root 3 and that will give us 1 upon 3, which is our value of r. Now we have a and we have r. Now remember, the sum of n terms, the formula for the GP is different if r, that is common ratio, is less than 1 and when it is greater than 1. What is our r? 1/3. So we have r which is less than 1. Therefore, we will have Sn given by the formula a into bracket 1 minus r to the power n upon 1 minus r. And so we will now substitute the values. Sn, we have been given this number. So we will write 364 root 3 upon 243 is equal to, what is our a value? It is root 3. Into bracket, now this is a fraction, so we'll put a box bracket here and we'll put 1 minus r is 1 upon 3 and that to the power n, and that upon 1 minus 1 upon 3, which is the value of r. Now let us see how to solve this. For some of you, it may be a little confusing because of the numbers which are there with the root sign, but not to worry. We will just follow each step systematically. Remember, just solve one step at a time. Now, in my numerator, I cannot do anything just now. So I will keep the numerator the same. In the denominator, 1 minus 1/3, Can we do mentally? 2/3? Yes. All right. Now, in our next step, we will take this to multiply this. So we will have 364 root 3 upon 243 equal to root 3 is divided by 2 upon 3 means multiplied by 3 upon 2, and this bracket remains the same. Do not touch this bracket. Now, these numbers that you see here, these numbers will bring to the left hand side. So, 364 root 3 upon 243 multiplied by this 2 comes this side, so it becomes a numerator, and 3 root 3 will go in the denominator, and this side, this bracket will remain as it is. Are you with me? Now, root 3 got cancelled. Can we do anything more here? We have to just multiply this number because 3 cannot divide this, 2 cannot divide this. So, 2 4s 8, 2 6 12, and 2 3s 6, and carried over 1, that is 7. And here we'll multiply 3 3s 9, 3 4s 12, carry 1, 3 2 6, and 1 7. And that is equal to 1 minus 1 upon 3 to the power n. Now slowly we have to come towards this n. But remember, this term is minus, so we'll bring it the other side, so it becomes positive. So we will say therefore 1 upon 3 to the power n is equal to 1 minus, and take this number, take it that side, 728 upon 729. Are we understanding what's happening? Now, 1 upon 3 to the power n remains the same, and here we will take LCM 729. Now, in the numerator, it will be 729 minus 728. Simple subtraction gives us 1. Now, 1 upon 3 to the power n should be 1 upon 3 to the power something. So 729 must be the power of 3. Now if you divide by 3, you will get here 243. Now 243, which is here, you know it is 3 to the power 5, because this is 81 into 3. So it is power 3, and this makes it power 6. So we shall write it as 1 upon 3 to the power n is equal to 1 upon 3 to the power 6. Remember, power of 1 to the power 6 will remain 1. Now, can we see that the bases are same? So the exponents must be equal. So we'll say therefore n is equal to 6 by equating the exponents, as the bases are same. And so we have how many terms? 6 terms. So we have n equal to 6 terms, and that is our answer. Let us come to the third question. The first term of a GP is 2 and its fifth term is 1 upon 8. Find the sum of its first 10 terms. Now, what have we been given? Let us look at that. The first term, which means A1, which means it is A, and that is equal to 2. The fifth term is A5. A5, which is the fifth term, is going to be AR4. Which formula have we made use of? Do you remember this formula? So A5 becomes AR to the power 4 using this formula. Now we know that AR4 is given as 1 upon 8. And so what we are going to do? We are going to find the value of r. So we will take the ratio of a5 upon a1 so that we will have ar to the power 4 upon a, which will be equal to 1 upon 8 divided by 2. Now why did we take the ratio? So that we could cancel this. So we eliminated a, so we'll have r to the power 4 will be equal to 1 upon 8 divided by 2 means multiplied by half, which is 1 upon 16. Now isn't this 2 to the power 4? So should we write? And so we will have r, which will be the fourth root of this. So here fourth root is going to be 1 upon 2. Now remember, we have to find the sum of its first 10 terms, which means I'll have to use SN formula. Now remember SN formula again, there are two formulas when r is greater than 1 and when r is less than 1. Now this is half, which is less than 1. And so we will say since r is less than 1, our SN formula becomes a into bracket 1 minus r to the power n upon 1 minus r. Let us see how we can proceed with this. Our a value is 2. 1 minus, now I'll put this as a box bracket, and here r is half to the power n. Now we want the first 10 terms. So remember we are finding S10. So this will be to the power 10. And here it will be 1 minus half. Let us continue simplifying this. So 2 into bracket 1 minus 1 upon 2 to the power 10 is going to be 1024. Now what you could do is just understand that we have 2 to the power 1 is 2, 2 to the power 2 is 4, to the power 3 becomes 8, 4 becomes 16, 5 becomes 32, 6 becomes 64. I think I'll just write here. 2 to the power 1 is going to be 2, 4, then we have 4 2's 8, 16, 32, 64. Are you getting it? 7th power will be double of that, 128. 8th power is going to be 256, which is double of this. Then we have the 9th power, which will be 512, which is double of this. And the 10th power will be double of this, is 1024. Okay. Now denominator is going to be 1 minus half, that is half. So we will have 2 multiplied by 2 upon 1. We are dividing by half, so we multiply by the reciprocal. And here inside the bracket, we will have 1024. And the numerator will be 1024 minus 1, which is 1023. So what do we have? 4 into bracket 1023 upon 1024. Now this is a power of 2, this is a power of 2, so 4 will go directly here. 4 2's 8, remain 2, 4 5's 20 and 4 6's. So we have 1023 upon 256. Now remember 256 goes 4 times 1024, and so it is 1023. In that 256 will go 3 times. Now when it goes 3 times, how much will be the remainder? Let's check it out. 256 multiplied by 3 is 3 6's 18, 3 5's 15, 16, 1, 768. So now 768 will be subtracted from here. So 1023 subtract 768. Now how much do you get here? 255. So you will have 255 and here upon 256, and that is our answer. We can just put a column here for our rough work. So I hope you have understood how to solve such problems on geometric progression. Thank you for watching.